from Madagascar. It's first time I hear that we have this new country in our conference. Please share your screen, and you are welcome to start your speech. We see the presentation.
Okay, wait a minute.
And we hear you.
Good afternoon, everybody. I am Professor Ravalison from the University of Antananarivo, Madagascar. Indeed, my first time with the TRIZ Summit today, and I'm very happy to host you to listen to my presentation entitled Improving the Efficiency of an Electric Power Company Using the TRIZ Methodology, the example of a state-owned company in Madagascar. First, let's see what is Jirama. That's the enterprise we're going to talk about during that presentation. Jirama, or Jirsan Malagas, is a state-owned electric utility and water service company in Madagascar. So it supplies electricity and water in Madagascar. That's the key sentence you have to get for that definition. For that slide, we're going to present some key informations. Key informations about accessibility first, and then key information about electricity production, this one and this one, and then a key information about financial of that enterprise. So about accessibility, 72% of urban population has access to electricity for the time being till now. And 10.9% of rural population has access to electricity. 35.1% of population has access to electricity. That's the scheme of accessibility to electricity. Concerning production, annual production is 1,900 gigawatt hour. Sales deficit of $0.11 per kilowatt hour. Production cost of $0.24 per kilowatt hour, and technical losses 28%. Besides, there was information about electricity. 57.7% of production is from fossil fuels, 45.3% of oil, and 12.4% from coal. 42.3% from renewable energies, and among that quantity, 39.4% hydroelectricity, 1.4% biomass, and 1.4% solar. That's the scheme of Jirama. Definition, accessibility, electricity production, and the important thing to know is it registered loss of $150 million in 2022. So you can evaluate, you can assess the dimension of the problem in terms of financial. The objective of that presentation is to identify an ideal solution to improve the performance of JIRAMA. Ideal solution is a solution we think that derives from TRIZ process, and we think that it permits to extract JIRAMA from the big problem where it is now actually. The plan is elaborate a problem stream mapping. Okay? Based on the lean process, we try to elaborate a problem stream mapping. Then from that problem stream mapping, we choose a problem and proceed a root cause analysis. Through a root cause analysis, we determine the root cause of the problem that we have chosen from the problem stream mapping. And then we apply TRIZ process to identify the specific solution. And the last point of the plan, we check matching of specific solution with specific problem, but this time based on financial angle. As you know, one of the big problems of that enterprise is a financial loss every year of US dollars 150 millions. After that plan, we'll define the performance of JIRAMA as an electricity supplier. We base our equation through international publication about power transmission and distribution losses, a model of available empirical data and future trends for all countries globally. That's the publication in which we have extracted the model energy losses rate equals energy lost divided by energy injected. Each terms of the question, specifically energy lost, is technical losses plus non-technical losses. About energy injected, there are two types of energy, supplied and injected by JIRAMA, and then second type, supplied by private enterprises, then bought and injected by JIRAMA. So there are two types of energy, supplied and injected by JIRAMA itself, and supplied by private enterprises. Technical loss, the performance of an electricity company, the technical loss is around 4 to 15%. But the technical losses in Madagascar is 28%. So we are going to elaborate the problem stream mapping. Okay? We have JIRAMA here. JIRAMA produces electricity through hydroelectric or thermal groups, and then inject that in its electrical interconnected network so that it can sell it to households here at the right side or to the enterprises. That's the first case that JIRAMA produces electricity and sell it to customers. And besides, we have electricity supplied by private enterprises. They provide solar electricity, thermal group electricity, or hydroelectric, and they sell them to JIRAMA, and then JIRAMA injects it in its electrical interconnected network. That's the problem today. The problem is Ginama buy here, for instance, $1 per kilowatt and is obliged by the state government to sell $0.60 per kilowatt. So there is that I call sales deficit. That's the very big problem. And let's try to translate that into a value stream mapping, problem stream mapping inspired from lean concept. Okay, we have a problem stream mapping here based on lean management concept. We have the electricity governance here. You start with production, electricity production, to sell it to the customer, and we follow that process. Okay, production, transmission, distribution, and selling. About production, we have a problem related to production cost, US dollar 0.4424 per kilowatt. That's the first step of problem, the cost of production. The second step is at the stage of production, transmission, distribution, a technical loss of 28%. A big problem related to 4 or 15% as a standard in electricity production. The selling is a selling deficit of US dollar 0.11 per kilowatt. Okay, and as you see through that problem stream mapping, the big difference about selling deficit 0.11 and the production cost 0.4024, approximately 114 US dollars per kilowatt as loss at every operations. A global loss of US dollar 150 millions here all along the process. That's the problem of that enterprise. If you want to see it through problem stream mapping. Here, for example, we have to choose one problem. Indeed, you cannot solve all problems at the same time. Production problem, selling problem, transmission problem, etc. So we cannot solve those three problems at the same time. We have to choose for that presentation. For that presentation, we have to choose because our time is a bit limited. 20 minutes of presentation and 10 minutes of questions and answers. Okay, and I think that you will have some questions related to that example of an African country who encounters some problem about energy. Well, we'll choose technical loss of 28% among those three problems. So we proceed a root cause analysis. Technical losses. So we're going to map what is the causes, what are the causes of technical losses. So we try to based on some international publication, but we are also based on realities, on problem at the companies itself. There are 5 causes. Okay? Long distribution lines, installation of distribution transformers away from load centers, unbalanced feeder phase current, inadequate size of conductors for distribution lines, and overloading of lines. Those are 5 causes, determinant causes. But when you analyze each cause related to another, each cause to another, we see that the determinant one is long distribution lines. Okay, long distribution lines is more determinant. So if we solve long distribution lines, we can tackle installation of distribution transformers, unbalanced feeder phase current, inadequate size of conductors for distribution lines, and overloading of lines. Okay, so we have to tackle here one determinant cause, long distribution line. Here then I sum up. We start with technical loss and we extract a determinant cause, long distribution lines. Then we will use trace matrix process. What trace matrix process is? We start with specific problem. We abstract that problem into generic problem. Okay, and we identify what parameters will suffer when we will try to improve generic problem. We use matrix, 39 features of conflict matrix, trace matrix, to determine generic solution, which is from principles of resolution. And from generic solutions or principles for resolution, because with matrix, we have a matrix in the first row, first column, we have the features to improve, and first row, the features that will decrease, that will be worse if you want to improve the column, the factors, the parameters in the column. Okay, and that matrix will give us an intersection with the row and column generic solution. Okay, we generate solution from generic solution to get specific solution. But we cannot stop there. We have to keep on. Why? Because specific solution must match with specific problem. And when we arrive at that stage, the process is finished. That's the trace process. And in the case of GDAMA, we'll try to use that to identify solution for the core determinant cause we identify in the root cause analysis. So here, as a specific problem, we have long distribution lines. I say again, we see that it's determinant among the causes of the problem we have explored in the root cause analysis. Okay, abstraction of long distribution lines. In other words, we try to translate long distribution lines in a generic problem, in some features of conflict, so we can say length of stationary object. That's the first step. I mean first step because I start with the problem here and I abstract the problem with a length of stationary object. With trace matrix, we will identify generic solution. Generic solution is the intersection of improving parameters and worsening parameters. The intersection will give us the generic solution or principles of resolution. Well, when we want to improve length of moving object, the worsening feature is the power, electricity power will decrease. The stability of the object's composition will decrease. Loss of time, of course, a worsening feature, and the quantity of substance or the quantity of the matter. So you see in the right, in the left, improving feature, which you want to improve, okay? And in the right, what will be suffer. If you want to improve the right, the left will be will suffer. That's the balance you will get when you apply TRIZ matrix.
Dear Professor Ravalison, you have 10 minutes before we finish the second. Mm-hmm.
Pardon?
Yeah, please, you have 10 minutes for the question and to finalize the speech.
Okay, yeah. I will finish it later. Okay, rapidly. Left of moving, so you are worsening features here. The intersection of worsening features and feature right will give us the generic solution. Generic solution for power is 135. For stability of object composition, 1, 8, 15, 34. Loss of time is 2, 15, 20, 29. Quantity of substance is 29 and 35. Then the principle 1, 2, and so on till 35 principles, we will identify, will generate specific solution, segmentation, decentralized hydropower, okay, dynamics, pneumatics, discarding and recovering, parameters changes, energy coupling, energy sources coupling. So from principles, from generic solutions, we generate some specific solution. Now we're going to check if long distribution lines match with specific solution. So here we identify that long distribution lines match with decentralized hydropower or hydropower for enterprises and hydropower for households. So electricity supplier will be it will be independent for each group of customers, enterprises and households. And then this ends my presentation. Spasibo. I'll be available. I'll be at your disposal for any questions. Okay, I'll try to bring you some elements for your questions to complete the explanation of my presentation. Thank you again. Thank you, TRIZ Summit 2023 team.
And I thank you very much for your efforts and sharing us this information. The project is very interesting, and actually it reflects two basic issues for trees: the IFR modeling, the ideal final result, which we started at the beginning for modeling the problem, and also the integration features with other methodological approaches like lean, and that was very interesting. I am switching to the questions now. If we have in our chat, so I can address it. Yeah, we have a comment from Mikhail Rubin. What other companies? Sorry, this one. Yeah, maybe Professor Ravalison, how does the university interact with the energy company? Based on some kind of contact, for example, or who is the initiator of the interaction?
Well, for that, thank you for your question. You see, we have started to utilize TRIZ method since 2004, and we to start that project, we have invited some key persons in the state-owned company to make a conference at our university about the energy problem related to governance, related to price strategy, about those two topics. And with them, we discuss how university can contribute in terms of solution or in terms of path solutions. And there, the initiative, of course, starts from our side, from the University of Antananarivo, specifically from our doctoral school. And then we work with enterprises who shares us the data, the problems, okay, in order that we can apply in their specific problems. So initiative is from our side, that collaboration is, the initiative of collaboration is from our side, and the collaboration is from enterprises and from ourselves.
Thank you for your answer. And what other companies do you cooperate with in the application of trees?
Well, yeah, till now, we work narrowly with the electricity providers, that the first, and then we work with the garments factories in Madagascar. Garments factories, we work with them with lean manufacturing, but when there is a problem we have to solve, we use trees method. We have, for example, for the time being, with my doctoral students, we work with the with the paper mill industry and 3 garments factories for the time being. But before, we have a lot of enterprises working on garments factories with them we work together.
Thank you. Well, dear participants, we still have spare of time for a few minutes to address any question to the speaker and for his presentation. Please, you are welcome.
Yes, another questions?
Yeah. Anyway, we have the break time is closer to our schedule. So if no questions by now, I thank you, Professor Ravalison, for your visiting us, and hopefully you will participate again and again with new interesting projects, and we will be very happy to again. Thank you.
Yeah. Thank you.
Okay. So, dear participants, now I think we have to start our break time. It will be until for 30 minutes. Oh, no, sorry, the timing is changed, so it's just for 15 minutes. So we are waiting for you to continue our presentations and speakers. Yeah. Now time for break until 3:45.
Thank you, Ramesh Kasu. Thank you again, Ramesh Kasu, and thank you to the Trees Summit.
Thank you. Thank you again. Thank you.
Okay.
Bye-bye.
Bye-bye.